Hey, I'm Ed from Seldon. In the next few minutes, we'll go through an introduction to Seldon Core and how to get started. Before we get into too much detail, let's answer the question, what is Seldon Core? The simplest explanation is that Seldon Core is an open source framework that lets you deploy machine learning models on top of Kubernetes. It works by taking your machine learning model and deploying it as a production microservice that can handle REST or gRPC requests. The deployed artifacts contain the necessary dependencies for inference, as well as being highly optimized and scalable. Seldon Core is totally framework agnostic, so whether you're building models with PyTorch, TensorFlow, or XGBoost, you can deploy your models in the same way. Now that we've established what Seldon Core is, let's take a look at how it actually works. When you tell Seldon Core to deploy a model, the first thing it's going to do is go and grab your model from wherever it's stored. This might be an object storage bucket on something like S3 or GCP, a Hadoop distributed file system, or even in Dropbox. There are over 40 storage types supported. Once Seldon Core has your model, it starts it up on a relevant, highly optimized server that fits your model's requirements. For example, if it's a scikit-learn model, Seldon Core will run your model on our prepackaged scikit-learn server, which includes all the libraries and frameworks needed to run inference on a scikit-learn model. As well as deploying your model for you, Seldon Core also creates the appropriate routes over the top of your deployment so that your model can easily be accessed through a REST API or over gRPC. All of this happens on top of Kubernetes, which brings three key benefits. 1. The scheduling of workloads across your infrastructure is taken care of for you. 2. Seldon Core can integrate with the full suite of cloud-native tooling. For example, if you have a Prometheus server, Seldon Core can automatically send metrics to it. 3. If you want to get down into the nitty-gritty, everything is totally configurable underneath, just like Kubernetes. Out of the box, Seldon Core can serve TensorFlow, PyTorch, scikit-learn, XGBoost, MLflow, MLlib, LightGBM, and Hugging Face models, as well as models using optimization frameworks like Onyx, TensorRT, and OpenVINO. If your model wasn't listed or contains custom logic, don't worry. You'll still be able to deploy easily using the custom wrappers for languages like Python, Java, or C++. Okay, so we've covered what Seldon Core is and how it works. Let's take a look at how we actually use it. First up, you're going to need to install Seldon Core. The best and easiest way to do this is to follow the relevant installation guide in the docs. We've got them for all the major cloud providers as well as running things locally. The only real requirement for this is that you have a Kubernetes cluster running somewhere. Once Seldon Core is running, you create deployments on your cluster by providing the config for a Seldon deployment object. Let's take a look at what that looks like. For those of you familiar with Kubernetes already, you'll notice the similarity to a Kubernetes deployment object. There are two main sections, one for defining deployment metadata and one containing the spec for the deployment. Within the spec, as a bare minimum, we need to define the location of where the model is stored and the type of model being deployed. In this example, we're deploying a scikit-learn model. Having defined our Seldon deployment, we can create it on our cluster using the kubectl command line interface or interacting with the Kubernetes API. For example, kubectl apply my model. Once our model is deployed, it's ready to start receiving requests over HTTP or gRPC, but it also gets deployed with an interactive UI, which we can use to send requests and view the responses. We've now been through what Seldon Core is, how it works, and how to get started. Let's highlight a few of the more advanced features we'll find useful once we start deploying models into production. The ability to dynamically route traffic during deployments, meaning we can run shadow deployments or A/B tests to determine how a new model performs before promoting it. Full logging of all requests and responses from your models, which can be used for evaluating model performance, auditing predictions, or storing samples for retraining. Automated scraping of metrics to a centralized metrics server, allowing us to identify resource bottlenecks or scale our deployments based on infrastructure metrics like CPU and memory usage. We can add detectors alongside our models to do advanced data science monitoring and alert us when things like outliers or data drift occur. On top of this, We can add explainer endpoints to our models, meaning users or applications can request explanations for why certain predictions were made. There are worked examples for both basic and advanced use cases in the docs, so make sure you check them out. If you don't find what you're after, come hit us up on Slack or join us on one of our community calls. We'd love to hear your feedback.